So today we're going to do a little tutorial on Objective-C. We're going to build classes, so it'll be like a little bit of object-oriented. There's a lot of things that I'm going to leave out that you'll have to research on your own, or probably a next video will cover. So the first thing is you open XCode. I have XCode here. You click and create a new project. And we're going to, just to try Objective-C, we're not going to deal with the emulator for the iPad or anything like that. We're just going to do a simple Macintosh application. So within the Macintosh application here, in Macintosh OS X, you go to Application and click in Command Line Tool. That builds basically a console application that is not graphical, it's not Flash, it's not, beautiful. It's just something that you can run from a command line. Click Next. You're going to give it a name, so we're going to call it the Alien Game, or Kill a Creature. How about that? It's going to be a game where you actually are going to, where randomly, two creatures are going to be fighting with each other, and we'll see which one dies first. So call it Creature Fight. Okay? Creature Fight, or CF for short. C Fight. Okay. It's going to be of type Foundation. Sometimes you have C here by default. Make sure you've switched that to Foundation, because we're going to work with Objective-C Foundation classes. And check the Use Automatic Reference Counting. I'm going to explain what that is as I go along. I'm going to try to make this a little fast because I'm running short in time. But alright, so where are we going to save it? It's going to be in the same folder where I have other projects. I'm going to probably create a new folder here with C Fight with the same name of my application. You can name it anything you want, but naming it the same name of your application, it makes it easier to find. And then I hit Create. So this has created an application for me already. I'm going to minimize my recording tool. This has created an application for me already that if I run it, click on Run here, it's going to compile it. You can see the progress, and then it's going to run it. And nothing happened because I didn't have my debugger open. Oh no, here it is. So the debugger opened and something happened. It said Hello World. That's the output. So by default this creates a Hello World application. Let's take a look at this. The Hello World is in the main.m file. Sorry, just one click opens it up in this area. Here, it's the main.m file. It goes with this directive auto release pool, and then it logs to the screen Hello World. Okay, so that's all nice and fine. Now, the thing that we're going to do is we're going to create classes here, and classes are comprised of two files: an interface or header file, which is a .h file, and an implementation file or .m file. So the first thing I do is I click on the folder for C Fight, and I'm going to go File, New File, and then I'm going to pick, it's going to be an Objective-C class. So I pick this type of file over here, and I click Next. The class is going to, my class is going to be named Creature. Okay, and it's going to be a subclass of NS object. All classes can inherit, just like in any object-oriented programming. Inheritance is you can only inherit from one object. So if this class doesn't inherit from anything, at least inherits from NS object, which is the basic baseline object for Objective-C. Then here it tells me, basically how is it going to save it, the target and stuff. You just say create. And what this did is it created two files here that are highlighted. You can see them right here. One is creature.h and one is creature.m. Creature.h. Creature.h, which is the header file, first starts with the directive import foundation.h. Import tells Objective-C which classes or which things you can use within your class. Foundation is all the basics that you need to develop. Basically, that's all you need to know right now. And the fact that it's in angle brackets tells it that it's a systems library. we will define our interface or our header file between the words at interface and at end. So in here, okay? So to define our class, first we could create instance variables or IVARs, okay? IVARs are used in the class instance. They're obsolete in coding right now, but it's not a bad practice just to see what the class is doing internally. We're just going to code them. You could omit them, but we're just going to code them just so you see the class. So for the instance variables, you have to open braces here, and you code them in there. These are like the private variables that the class is going to use, okay? And you can declare them public or private, but these are the private variables. And let's say for my class, I'm going to create a string, which is an ns string, next step string, star, and name. All objects in Objective-C are pointers. Therefore, you always want to have a star next to them, okay, when you declare them. But then there are basic types of objects. For example, the Boolean type, which is special because you can use the bool in C, but it's not recommended. But the bool with capital B-O-O-L takes the values yes or no, not true or false, but yes or no, and that's the type preferred by anything Macintosh. So all the libraries work with that, rely on you using this type for communicating with other libraries and so on and so forth. So we'll see, if this creature, you can have a lot of things here, but let's say this creature has a name and a strength. So bool would be a yes/no variable. You can have a strength here. So we'll say bool, is this creature a mammal? Mammal. And then we're going to create an int called strength. Now, it's common practice that these independent variables have an underscore in front of them. This this internal variables, these private variables have an underscore in front of them. So that's how you would declare implementation variables, right? So, or instance variables, IVARs. Now, for all these variables, it is common practice to use a getter and a setter. Now, to get and set all these variables, you would do something like you would declare a method such as void. I'm going to explain the syntax in a bit. Void set name, right? Set name, and then you would set, you would take in a name and then you would set it into underscore name. Now, the thing that Objective-C does for you is that it does all this for you if you tell it that there's a property, and then some parameters, read, write, assign, and strength, for example. That's telling the computer, that's telling the compiler that there is a property called strength. And that's going to have, that's a candidate for having a getter and a setter. Now, we're not telling that the property, so for example, set strength, we haven't tied it to underscore strength yet. We're going to do that in a bit. Okay? And then there's another property, for example here, property, which is read, write, assign, and then this is going to be a string name, right? Again, we haven't told it that the property name actually sets the values of underscore name, right? So again, this underscore here, underscore name could have been named Bob, and we have not told the compiler yet that name is going to set the value of Bob yet. We haven't tied these two together. Now, so in an interface file, we declare the properties, the variables. The interface file is like the blueprint of my object, okay? So then I have some variables, some properties, and it can also have some methods. So for example, a vari an animal or a creature can bleed, you know, with a certain rate. So it bleeds at, you know, however rate, you know, it bleeds. So and then the other method that it can have is could be, for example, it can recover from wounds. Recover, which is a much more positive message, at a certain rate as well. Okay, now let me explain what this is. This minus here indicates that these are instance methods. Okay, these are methods from the instance. So whatever, if your creature is named Al, it'll be Al can bleed at a certain rate, and you know other creatures can bleed. The other alternative is to have a plus sign here, which is a method of the class. So creatures can a creature bleeds. It's a method of the class. It modifies, or it's part of the class. You don't need an instance to call that method. You can just call it in the class. Okay. So NS-strings, for example, have that, where there's a method not on a particular string, but the class string has some methods, you know, to get a substring or to format the string or something like that. And those are methods of the class. You don't need an instance of a string to do these. Here we've created the bleed method and the recover method. Okay? And those are my methods. Now, a little note on this part of the properties here, for example. Okay? You can have, in a property, you can have a lot of things there. Assign means that it directly assigns the var to a hidden instance variable, to a hidden ivar. This must be used with primitive types. And then the read-write means that you can have a getter and a setter. You can have a read-only, you can have copy retain, which controls the lifetime of the object, strong weak, which controls how memory management works. You can also name a setter and a getter that are different for these classes. So for example, I can have property read-write, assign, and then this is another one, atomic. They're all atomic by default, so I'll say non-atomic. And then bool mammal, right? I want a property for the mammal, but then I want the setter, the getter, I'm sorry, the getter to be called, you see how this is completing this for me? To be called isMammal. I don't want it to be called mammal, just mammal or get mammal. I want to call it isMammal, so I can ask the question whether it's mammal or not. So I can define the setters that way. Now, another note on the methods here is that I have this is the way it works. Modifier, class or instance. Return type, which can also be void if you don't want to return anything. Some methods do just stuff, but they don't return anything. So int bleed, that's the name of the method. And here are the parameters, so the rate at which it bleeds. If I had more parameters, for example, if I were playing a game, you know, perhaps I would have a method like this. Move piece, colon, and then a character, the piece that I want to move, P for pawn, R for rook, and so on and so forth. Then 2, and then direction, so that would be up, down, you know, or whatever. So a card saying U or D or whatever. So this is the way I do it. In Java, you would do it, or in other programming languages, you might do something like this. Int move piece card piece card direction, and you omit the word to. Okay, we'll see how calling this method here makes sense, because then you'll call it as move piece P to U for up, for example. You might say something like that, but we're going to talk about that later. Just know for now that return type, modifier, class, or instance, return type, name, and then parameter, and then you're going to have another keyword, and then another parameter, keyword, parameter, and so on and so forth. Okay? So now we save this class. And the other end of this is we've set the blueprint in the header file in interface. Okay? Now we need to set now the implementation of this file. So the implementation goes into the .m file, okay? And whoops, I'm sorry about that. And the implementation goes into the .m file. Why .m? Google it up. I don't think anyone knows the reason except that it's not C and it's not H, you know, so it's just a different letter. Now, the implementation for creature, it goes into creature.m. That's the file name, okay, creature.m. Now, it says import creature.h. The first thing that this does is it tells my my implementation where to get the interface. Where's the blueprint for this implementation? It's going to be in the file creature.h. It doesn't have angle brackets because it's not a system interface. It's an interface that I created. Okay, so then that's what it brings. Now, then it says implementation creature. Here's where I'm going to start implementing creature, and this is where my implementation is going to end. And the implementation goes like this. Remember, we had two properties that we needed to tie to variables. Okay, if I go to creature.h, you can see this. I had these properties, three properties that I wanted, three properties, strength, star name, and mammal that I needed to tie to name, mammal, and strength. Okay, now, yes, I'm just checking the warnings. Now, so I need to tie those variables, I need to tie these variables, name, for example, to underscore name, strength to underscore strength, mammal to underscore mammal. Okay? So in order to do that, I have a compiler directive called synthesize. Okay? Synthesize, and then the property, strength. That is going to create a get strength and set strength. But it's going to set it to a variable named strength. What I want to do is I wanted to set it to a variable name underscore strength. Okay? That's how I tell it to do that. If I omit the equals dot underscore strength part, it's going to create the variables. It's just going to set it to variables of the same name. Okay? Which is totally fine. I'm just showing you I'm protecting the underscore strength variables here. You know, I'm making those private, and then I can use those variables. But really, truly, you could totally do without the underscore variables and the ivars that I declared. Okay, the compiler's now pretty smart. This is like the old way, and you will see a lot of programs like this. This is why I'm covering it, and it's important to know what strength is doing internally, or the synthesize is doing internally. Now, the other property that I need to synthesize, right, is name. I'm going to set it to underscore name. Okay, so I'm going to synthesize name, and it's star name. I'm going to synthesize it to underscore name. I have an error here, which says expected a property name and synthesize. Yeah, name is now property name. So, yeah. So now, why is it complaining here? Let's see if we can fix this. And string name, so it might have the star, might need the star here. Oh, does not need the star, does it? Needs the star. We'll put the star. We'll figure that out in a second. Now, the other way to do the other thing that I need to implement is the bleed method. So I'm going to implement it, int bleed. I have to retype the method definition. Okay, I have to retype the method definition, but instead of semicolon it, I'll just put the curly braces and implement it. What I'm going to do, when it bleeds, it reduces, the creature reduces its strength. So what I'm going to do here is I'm going to do self strength. Okay, so self strength will become self strength minus rate. What I've done here is, close the braces. What I've done here is self strength. For right now, I'm basically passing a message. Self is my class, is my creature instance. So to this instance, call the strength method, which is the setter, which is the getter. I'm sorry, it's that's the getter. So self, I need to call the setter. So my bad. Set strength. Set strength right there. And set strength. So here I'm calling self set strength. I'm calling the setter from this instance. Okay, I'm passing a message to the instance saying, hey, set strength. And I'm gonna use self strength. This is the getter for it's here. That's the thing. It completed myself a little bit weirdly. Okay. So I'm gonna say self set strength. Okay, and I'm gonna set the strength to the current value of strength for this instance. This is calling the getter minus whatever rate I pass. Okay, and then I close that one and close the other one. Close the square braces. I don't think I need to close two. I don't think I need to open two. All right, that's it. So again, to recap, square braces, self set strength. That's basically telling the instance to set the strength, to set the property strength. That's the setter. And then the value that's going to be set to, okay, the parameter I'm going to pass is this, is its current strength minus a given rate. Okay? This is interesting because the syntax for this is open braces, receiver, in this case self, message, which is set strength, okay, that's a message, and optionally the parameters that it needs, okay? So parameters here, parameters, okay, if it has some. So here the parameter is, so, and then of course close, close the square braces. Now, the parameter in this case, I'm saying, hey, get me the strength of self and reduce the rate. That's the parameter I'm passing in, okay? So that's the bleed method. And in the same vein, the recover method, receives an int, which is the recovery rate. I'm going to open braces, and then I'm going to say, one could say, the other thing is because I have internal variables where this is all stored, I can totally say strength equals strength plus rate, for example. Okay? Now, because of memory management issues, it's a good practice to actually use the getters and setters. So although you can do this, okay, we can live there, but this version leaks, potential leak of memory, okay, because the setters and the getters do not only just set the value, but they also manage the memory of the objects. Because the iPad or the iPhone have very limited memory, you really need very good management of that memory, and built an automatic memory management system that's good and robust and incredibly fantastic is going to take up a lot of resources, and we don't want that. We actually, so then what Apple does and Objective-C does is it lets the user control the memory management to a point. So if I do this, I'm not doing any memory management at all. If I use the setter and the getters, those come with memory management encoded in there. This is why this is a potential leak. Now, and that ends my implementation. Now there's one more method that I need to code here, and this is a special method for all classes. It's what in Java is called the constructor. Here is the init method. Init, okay? So the NS object, which is a superclass of this, already has an init object. We are overriding it. That's why we don't declare it in the interface. It comes with the foundation.h and the NS object class. So for init, for example, the first thing we do is we do self equals super init, because we want to create all the initializations of the superclass first, so that's good, and kosher and everything. And then we want to say if self, we'll probably talk about that later. If self, then if self then we're gonna say a default strength, for example. Self set strength, set strength to 100, for example, and then self set name to add nobody. This is how you create strings in Objective-C. You precede them with an @ symbol. And we're going to talk about other stuff. Okay, so we're going to try to compile this. I have a bunch of errors here. Synthesize, so creature. This property has a warning. It says that it requires method name to be defined, right? It requires method name to be defined. So I need to define name. So in my implementation, I'll just define name. Okay. Now this one has an error that says underscore name for unsafe return property name must be unsafe retained. Oh, okay. So that means my property name needs to be retained, and this is one of the modifiers of properties. So if it's an object, copy is a good one. We're gonna, in the slides, you're gonna see what other options you have there for retaining an object. So for example, that will be that will copy it. You could also say retain. Retain means you care about this, you know, retain. You can say that. So you can retain. This is memory management. We're going to talk about that in the lecture. Now, and then we have a problem here with init. Method is expected to return an instance of its class. I'm sorry, it's not int, it's id init. Okay, so id is modifier, is like an overarching modifier. It's any type. So init returns whatever, you know, whatever returns, and then it actually returns the class itself. Okay, so once it's been initialized, it returns this instance, and it's returned that instance, right? So now this compile, and this, what is it saying here? Control reaches a non-void function. Again, I have a return type. I need to type in the return. Return, and then we're going to return self strength. We're going to return the strength of the object at every time it bleeds. And here is the same thing. Self, return strength, since we're using that. Again, this is bad practice, okay? I'm going to change the comment here. Bad practice. Okay? So I'm going to return strength. And why is it that it's not allowing me? Oh yeah, it's a typo. So I'm just going to let it complete it. Okay, strength. Now I can compile this. Of course, it's still going to print hello world because that's, you know, that's all I've done. The last piece here is that I need to go to my main, tell it, and then I need to go to my main and actually then use my object, right? So in order to do that, I'm gonna show you how to do this really quickly. There's, in the main class, okay, we're gonna use this. We're gonna import creature.h. Okay, we're gonna tell it that we're gonna use this, and in the auto release pool, okay, we're not gonna say hello world anymore. We're gonna do this. How about creating a creature, and I'm gonna call it grok just for fun of it, okay? And I'm gonna have another creature called Grick. Now, creature grok is actually gonna be, you know how in Java you say new creature, something like that? That's kind of what you would go about doing. In Objective-C, the way you do this is double parentheses creature alloc, okay? That allocates the memory necessary for the creature, and then you init it. That creates a new creature. The same thing for grok. It's going to be a new creature, which you create like this: alloc init. Okay? So we created two creatures. Now, we're going to have a little loop here, and loops are the same as in C and in Java. Say 100 times they're going to punch each other 100 times, where you're going to increase that, right? And what happens in this loop, I'm going to have a random number, for example, int random number, and that's going to be, this is a function for random, okay? Arc random. That creates a random number between, so modulus 10, that gives me a number between 0 and 9, plus 1 gives me a number between 0 and 10. Now, if that random number is greater than 0.3, for example, than 3, for example, okay? If random number is greater than 3, okay, that means 70% of the times, okay, what's going to happen is the grok will bleed. Look how it's complete. I'm sending the message bleed to the receiver grok, or basically calling the method bleed in grok. Random num times 10. So whatever the chances that this guy was going to bleed, I'll multiply by 10 and make it bleed like that much. And then Greek. But every time the grok bleeds, that means that the Greek hit it, so the Greek will recover. Okay, will recover 10 minus. Will recover a little bit. Okay, we'll recover 10 minus whatever that random number was. Okay. Now, in the case that in the 30% of the cases, then, which is that else, which is what this else means, Greek will bleed and grok will recover. Greek will bleed random num times 10, and grok will recover 10 minus random num. Okay? That's just very simple rules. And what I'm going to do after these ifs is I'm going to print nslog, okay, nslog, and then the string glick, okay, glick, and then I'm going to put an integer or decimal there, and then I'm going to say grok is having integer decimal. Close quotes, close parentheses, semicolon. This is my program. So now I'm going to compile it and run. I'm going to increase the size of the debugger if I can. I cannot. Okay, so I'm going to just compile and run. And you will see this in this screen down here. Oh, sorry. There's a little warning here. I was going to put an integer. Which integers am I going to put here? Well, Greek strength and grok's strength. Okay, so I'm going to pass these two integers, and this is not glick, but it's Greek. So I'm going to compile it. I'm going to stop it. I'm going to run it again. Okay, so here it's telling me, you know, in the 100 times, let's see when it started. They all start, you know, Greek 101, grok 100, right? Grok 160, then Greek 101 and grok diminishes by 90. Greek is 104 and grok diminishes by 160. So, and then Greek starts diminishing here, and grok, you know, is way down in the negatives because it lost so much blood. So you can see them fighting here. It's a really simple fight, you know, but illustrates what you can do with Objective-C. So then we go to the File Explorer, and we see this. We can see our implementation creature.m. Instead of 100, I can say that this is going to be 1,000, right? And then here I should fix that to use the methods and not the variables. And in the main file, yeah, I'll recover by 10 minus the random number and 10 minus the random. That's fine. This is just a process by which I do stuff. So random number if a random number is between 1 and 10 is greater than 3, that means that 70% of the times this is going to be true, because it's a random number, so 70% of the time it's going to be greater than 3. And 30% of the time, this is what's going to happen. The Greek's going to bleed, the Grek's going to recover. 70% of the time, the Grek's going to bleed, the Greek's going to recover. Okay, so we expect the Greek to always be higher values than the Grek. All right, this concludes this video. I hope you enjoyed it.